With that, we move on to delay. You have two types of delay, radioradial and radiofemoral delay. Normally, when you feel for the peripheral pulse, for example, the radial pulse, you feel for both the radial pulse at the same time, and both of them should be felt at the same time. From both the radial artery, the pulse must be felt at the same time. Another, radial artery and femoral artery as well, same thing. When you feel the radial artery and femoral artery, from both of them pulse should be felt at the same time. If one is felt before other, that means there is a delay. The delay can either be in between the two radial arteries or in between radial artery and femoral artery. If it is in between the two radial artery, we call it radioradial delay. If it is between radial and femoral artery, we call it radiofemoral delay. First, let's look at the causes of radioradial delay. You don't need to mug up, you can use your logic here as well. You need to know the basic anatomy of circulation of blood, where the blood is coming from to supplying the upper limb. See, this is the ascending aorta, then the arch of aorta, then the descending aorta. From the arch of aorta, on the right side comes the brachiocephalic trunk, which splits into subclavian artery and the common carotid artery supplying the right side. On the left side, you have the common carotid artery and the subclavian artery arising separately. So, for radioradial delay, what can happen? Number one, from below upward. Here is your aortic valve. There can be supravalvular stenosis. Supravalvular stenosis. Supravalvular stenosis, which is associated with Williams syndrome, which is characterized by a triad of congenital supravalvular stenosis, mental retardation, and hypercalcemia. Along with that, you also get to see, due to supravalvular stenosis, something known as Coanda effect. What is Coanda effect? See, here is a glass of water, and let's say you pour something out of this glass of water, right? You're pouring, let's say, I mean, glass of water containing water. You're pouring something out. When this water falls down, it trickles down and then touches the wall of the glass, and then it falls down. This effect is known as Coanda effect. So the water, as it falls down, it touches along the wall of the glass and then it falls down. Similarly, in supravalvular stenosis as well, as the left ventricle contracts, what happens is that as the left ventricle contracts, the jet of blood has the preference to take the right hand side. So the jet of blood that gets squeezed out from the contraction of the left ventricle, in case of supravalvular stenosis, has a preference to follow the right subclavian artery. As a result, the right-sided upper limb pulse comes before the left-sided. Not only that, the right-sided upper limb pressure is more than the left side. So that was the first cause. See, another thing that you need to know is that all the causes of radioradial delay and radiofemoral delay will also lead to difference in blood pressure in upper limb and difference in blood pressure in upper and lower limb. I think that's quite logical. Okay, second is aortoarteritis. Let's say this subclavian artery has aortoarteritis or Takayasu syndrome, same thing, aortoarteritis, also referred to as pulseless disease. As a result, the flow of blood from here is less and the flow of blood from here is more. Third is coarctation of aorta, but pre-subclavian, before the subclavian artery. If there is pre-subclavian coarctation of aorta, more blood will go from here and less blood will go from here. So this is pre-subclavian subclavian coarctation of aorta. And then there's last. Let me draw a separate diagram. So this is the arch of aorta with subclavian artery arising from brachiocephalic trunk. This subclavian artery travels from above the rib, right? This rib is attached to the T1 vertebra. But sometimes you might have a cervical rib, that is rib which is attached to cervical vertebra. This is your cervical rib. Cervical rib. As a result, the subclavian artery gets squeezed in between the cervical rib and the first thoracic rib or the first rib. This is a part of thoracic inlet syndrome. See, this is what I mean. There is the C7, there is C7. So sometimes rib might arise from C7 and then get attached to the first rib and then cause stenosis or narrowing here, compressing the subclavian artery. So less blood will go from here, but more blood will go from here, causing a difference in blood flow between the two upper limbs. With that, you are done with radioradial delay. So the causes of radioradial delay are, number 1, supravalvular stenosis. Number 2, aortoarteritis or pulseless disease. Number 3, coarctation of aorta but pre-subclavian. And number 4, cervical rib. Radiofemoral delay. Again the same thing. Here's the arch of aorta, brachiocephalic trunk, subclavian artery supplying the right side, the left common carotid and the left subclavian artery. If there is coarctation of aorta after the subclavian artery, in this case, blood will go into subclavian, but then the blood flow is obstructed to the lower limb. So it will cause difference in blood pressure, difference in pulse in the upper limb and the lower limb. So first cause is coarctation of aorta. Post subclavian. Another cause could be if within the descending aorta there is some sort of blockage, then there is obstruction to the flow of blood, and this blockage could be either in the form of atherosclerosis or embolism or tumor from outside, whatever, and that will lead to radiofemoral delay. So that's your delay, radioradial delay and radiofemoral delay.